Okay, we're going to talk about significant figures, or sig figs, today. Alright, so sig figs, or significant digits, are numbers that have meaning, okay? They tell you how your measurement was. Tells you how exact or how accurate your measurement was. Your answer can't be more exact than your measurements were used. So if you use like a meter stick, you can't write your measurement out to the millimeter place, because that would be more accurate than your actual tool was able to measure. So we have to think about that with what constitutes as a significant digit. There are definite rules for determining significant digits. So this is all based on accuracy and precision. So using significant figures allow us to be accurate and precise. These two words get mixed up together in common day language. So here in science, just to kind of straighten it all out, accuracy means how close your answer was to the actual or true value. So if you got like a table from IKEA that said was 10 feet, and you measured it with your tape measure and you got 10 feet exactly, then yeah, your measurement was accurate. Let's say, so for precision, what that means is how repeatable your answer or your measurement was. So let's say you have that 10-foot table, you measure with your tape measure 3 times in a row, 9.5 feet. Well, your measurement was precise. You got the same thing over and over again, but it wasn't actually super accurate because the table is actually 10 feet. So looking at like this game of darts here to see this idea of accuracy versus precision, we got right in the bullseye, so you have a high accuracy, and you're pretty much on the same spots, so you had a high precision with those 3 throws. For situation B here, you're in the bullseye, so yeah, you're accurate, okay, so you have high accuracy, but your darts were not exactly like right next to each other, so it wasn't as precise as situation A here. Game C here, you're not very accurate, you did not get into the bullseye, but you got 3 shots right next to each other, so you were a high precision here. And then letter D, you probably, I don't know, spun around a bunch of times and just threw your darts willy-nilly. Your accuracy is terrible, you did not get near the bullseye whatsoever, and you are all over this dartboard here, so you had a low precision. Alright, so let's look at what numbers are significant when you look at a number here. All non-zeros are numbers, or are significant. So for example, here we've got 7 numbers that are not zeros, so those are significant digits. 7 sig figs. For the next one here, all zeros between digits that are not zeros. So for example here, 1, 0, 0, 3, these 2 zeros, they count. I'm going to switch over to red here to make it a little more, see better, there we go. So those are significant. They're sandwiched in between numbers that are not zero. So this 1 here and the 3. So we have 4 significant figures. For the next one here, so yeah, we call these sandwich zeros to be kind of cute, but whenever you have zeros in between numbers that are not zeros, they count. They are significant. Now here we come kind of more trickier when we have zeros that end a number. So all zeros that follow a significant digit when a decimal point is present are significant. Okay, so for example, if we look at these 2 numbers, 200, no decimal point. That is just 1 sig fig. We'll talk about that in a bit. Why? Well, first of all, there's no decimal point. Okay. Here, 200.0. That decimal point's crucial. That means we have 4 sig figs. Why this one 1 sig fig? Why is this one 4 sig figs? This 200.0 is indicating that someone made a measurement exactly to this 10th place here. So they're indicating, hey, I did a really accurate measurement all the way to the 10th place. I measured exactly on the dot, 200.0. This number here, 200 without the decimal point, is indicating that this is probably a rounded number. Someone could have been measuring something or like eyeballing something and it was like, 175, well, we'll round it up to 200. So no decimal point means it's kind of a rounded, not super accurate number. So that's only 1 sig fig. Okay, the next situation here, when a number starts with zeros, they are not significant. They are called placeholders. So, for example, this number here, all of these zeros are just indicating, hey, when did this person start their measurement? What place did they actually start, like, the actual accurate measurement? So they started this place here. Oops. Okay, so the 3 and the 4 count. Okay, these zeros do not. We have the decimal point here. So this is kind of following this idea here. All zeros that follow a significant digit, like this 4 here. And a decimal point, so that 0 counts because it's following a decimal point, and this 4. So we have 3 significant figures. These zeros, again, do not count. Okay. All right, so how many sig figs do we have on here in these numbers? Okay, so 0.20. Okay, this 0 is a placeholder, does not count. We have the 2 that counts. This 0 follows a decimal point. Okay. Ooh, let me zoom out. Don't want to zoom in. Okay. So here we have 2 sig figs. Okay. 1,230. There is no decimal points. No decimal points. So this 0 this looks like a rounded number. Okay, there's no decimal point saying we measured exactly 1,230. So that one does not count. So we have 3 significant figures on that one. 1.90. Okay, we have the decimal point. Okay. This 0 follows the 9, which is a non-zero number, and the decimal point. So that 0 counts. So we have a total of 3 sig figs here. 0.00125110. These beginning zeros, again, beginning zeros don't count. They're placeholders. They just tell us when did we start the measurement. These 4 definitely count. Now the questionable 0 right here, we have a decimal point, and we have the 0 following this 1, which is a non-zero number. So when you have this trailing 0 after the decimal point, it counts. It's showing us that we measured all the way up to this place, exactly to this point. So we have 5 for this one. What is this? 3 billion. Do we see decimal point? No. Okay, so this is a rounded number. We did not measure exactly at 3 billion. We rounded probably up or a little down. So this one has 1 significant figure. 175.0. These 3 definitely count. Decimal point with a 0 trailing after it, following another number that's not a 0. So yes, it counts. It's significant. So we have 4 sig figs. Someone measured it all the way to the 10th place, exactly to 175.0. All right, 10.0. Okay. We have the 1, and the 0 follows the 1 with the decimal point, and again, this 0 follows a 1 with the decimal point. So that counts. So 3 sig figs. Okay. Again, if you need to slow down, rewind, feel free to do that. Okay. Round some of these to 3 sig figs. We'll do a couple of these together here. Okay. So to round to 3 sig figs for this one, we ignore these non-significant numbers, the 3 zeros here, and we're going to look at these 3. These zeros count because they're sandwiched in between. This is going to practice scientific notation. So we want scientific notation. We want 1 digit, decimal point, and then we have our 0. The 0 here we have to round. We have to always figure out if we need to round or keep the last digit the same. So here we're next to a 5, so we have to round up to 1. And then we have to say, well, how many times did we move my decimal point? So times 10, which every time we move decimal point changes to a factor of 10. We moved it 1, 2, 3. 3 times. And this original number was less than 1. So that means we have a negative 3. Okay. 1,284,300. No decimal points. Okay. So these 3 digits here we want to use for a rounded significant or scientific notation number. So I have 1.2. Oh no, zoom out. Okay, zoom out. Sorry guys. All right. It's a little sensitive. Okay. 1.28 The 8ths we're going to keep the same because we're next to a 4, so we do not have to round up. Times 10. There we go. Decimal point to pretend decimal point, or the decimal point that wasn't present there. Oh no. Okay. The decimal point that wasn't present was right here. So sorry again. So we have to go 1, 2, 3, 4, 5, 6. We moved it 6 times. This number was greater than 1, so this is going to be a positive 6. Okay, last one here. Well, I think we're going to keep it there. Okay, I think we get the gist. Okay, let's move on. All right. Okay, so how do we use this for actually measuring? Okay, so we always use last digit estimation for measurements involving measurements without electronic devices, so like graduated cylinders and rulers. Rulers, generally we round to the hundredths place, which would be the centimeter mark. Graduated cylinders, depending on the size. So if you're using like a 50 or 100 graduated cylinder, which we use a lot, you measure to the tenths place because the tick marks measure to the ones place. And then the 25 and 10 milliliter ones are a little more accurate, so you can get an estimation at the hundredths place, so showing that those are a little more accurate. Okay, so let's do some practice here. So this ruler has a mark for every tenth of a centimeter. So here's 1 centimeter, and we have 10 tick marks here. So each little tick mark is a tenth of a centimeter. All right, so where would we estimate to? So the last digit estimation, whatever your device measures to, you always estimate to the next place over. So if this was the 10th place, measuring every 10th place, well, that means we're going to estimate every 100th place, which is the next one over, next place over. So this green line right here, it's like right before the second tick mark after the 8. So this is like 8.1, 8.2. So it's not quite 8.2. And again, we have to measure to the 100th place because you always have to estimate that. So it's not 8.2. So 8.1 almost to the second place or second mark. So it'd be like 8.18 or like 8.19. If you think it's right at the 2 mark, you would say 8.20. So you use that 100th place to estimate, well, how close are you to a certain tick mark? And each tick mark is measuring to the 10th place, so we have to measure to the next one over. Reading graduated cylinders, same idea. So we have to use the meniscus, which is this little dip right here. This graduated cylinder is marked at every 1 millimeter. So here, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60. So since it's measuring to the ones place, well, we have to estimate the next place over. So after the ones place, the next place to estimate would be the tenths place. So for this measurement here, let's see, 51, 52, 53, I don't know, 52.8, 52.9, somewhere around there. Okay, so we had 52.9 milliliters. Okay, so you have to estimate how close are you to the actual tick mark that you're measuring. All right, this one here is a little fuzzy. This is measuring, let's see, 6.2, 0.4, 0.6, 0.8, 7 is measuring every 0.2 milliliters. Okay, so we would measure to the 100th place, which is the next place over. So this one, let's see, 6.2, 6.4, 6.6, 6.8. It's not really at the halfway. It wouldn't be like 6.7 something. It's gonna be like 6.65. There we go. Okay, 6.65. So you use that 100th place over to estimate. Okay, that is it. All right. Feel free to, stop it, slow down, rewind it if you need to go over things more slowly. All right. Bye.